Alright, so this is the video for the change in dimensions and how that affects the perimeter, the area, the surface area, or the volume of different shapes and different solids. And we're going to go over each case, do one example of each one, and then you can try your second. So the first one we're going to be talking about is perimeter. And so this is a question you might come across, and it says the sides of a rectangle were lengthened by 7 inches. What was the effect on the perimeter? Okay, and so I think a good way to go about thinking about this is to actually draw a picture, right? Usually pictures help me, so I always recommend whenever you can draw a picture. And so it says we have a rectangle, so I'm going to draw a rectangle, okay? And it doesn't tell me the side lengths of the rectangle. It just says that they got bigger by 7 inches. So what I'm going to do is I'm going to make the original rectangle right here, and I'm just going to come up with side lengths on my own. They can be whatever you want, but I'm just going to make them up because that'll give me an idea of how to answer questions. So I'm just going to say maybe that side is 1, and so this side also has to be 1, and we'll make this side 3. You know, you could pick 2, or you could pick whatever numbers you wanted. I just, sticking with smaller numbers is probably better. And then it says I'm going to increase each one of these sides by 7. And so I'm going to make a new rectangle where each one of the sides is 7 inches long. So I mean, I'm not going to be exact here. I just know the rectangle is going to be larger. So my new sides, if this side was 1 over here, then this corresponding side, if it got bigger by 7 inches, is going to become 8 inches, right? And so that means over here is also 8 inches. Then this top one would go from 3 inches, and you add 7 to it, will make it 10 inches, right? And so this one down here will also be 10. Okay, and so it says, what was the effect on the perimeter? So what we're going to do is we're going to see what the perimeter of this smaller one is, and then see what the perimeter of the larger rectangular is, and see what the difference is between them. You know, how much did the perimeter get? Okay, and so if you forget, the perimeter is the distance around the shape. So it's the distance. If I were to take a ruler or something and I was to measure around this outer edge of this rectangle, what would that be? So it'd be 1 inch plus 3 inches plus 1 inch plus 3 inches. So that's a total of 8 inches. So on this one over here, the perimeter equals 8 inches. Okay? And that's an N. Alright, and then over here, again, same thing. Perimeter is the distance around. So if I were to measure, I would go 8 inches plus 10 inches plus 8 inches plus 10 inches, and I'm all the way around. And so that'd be a total of 36 inches. So that would be my perimeter here. Would be, perimeter would be 36 inches. Okay, and so what was the effect when I did that on the perimeter? Well, the perimeter went from 8 inches to 36 inches, and so that's a difference. If we subtract the two, if we do 36 minus 8, we want to see what happened here, and we would get 28 inches, correct? 28 inches is the difference. So the effect would be, your answer would be that the perimeter increased by 28 inches. Okay? So that's an example of how they would ask you about perimeter. And so the best way to answer a question of these, because they might use different shapes, they might use a pentagon or a hexagon or a triangle or whatever, is to actually draw the shape out and pick side lengths and then apply the effect. Okay, so on these, when it's asking about perimeter, make sure you draw a picture. Okay? Alright, so this next one we're going to talk about is about area. So let's read the question, then I'll kind of tell you how this works. Okay, it says each side of the trapezoid below tripled in length. Okay, and so that's a key word there, tripled. Okay, and so doubled would mean 2 times bigger. Tripled is 3 times as big. Quadrupled would be 4 times as big. Okay, so each one of these sides would get 3 times bigger. So this side would go from 6 times 3 is 18. This side would go from 7 to 21. You multiply each one of these sides by 3. Okay, and it says, what effect would this have on the area of a new trapezoid? Okay, and so here's kind of the important part. You got to read what it's asking about. And so for perimeter, I told you to draw a picture, but for area, you don't have to draw a picture. Okay, what you need to know for area is what's the units. Okay, if you can remember what the units are for area, then you'll be fine. So just to remind you, if we were to find the area of something, in this case it would be centimeters, our units would be centimeters squared, right? So area is centimeters squared. Okay? And if you can remember that squared part, all you have to do is take the number that this is getting bigger by. So this is getting 3 times as big. And what I would do is I would do 3 squared, because it's area, and area is always squared. So it would be 3 squared, or the area would get 9 times as big. Okay? So if it's asking about area, you need to remember that the units for area are always squared. And so what you're going to do is you're going to take that number that says tripled, and you would square it. So let's say this said quadrupled, right? So we got 4 times as big. Okay? What you would do then is you would do 4 squared, and it would be 16. So you look at how many times bigger it got, and then you take that number and square it if it's area. And again, the reason why you're squaring it is because it's area, and the units are always squared for area. Okay, let's look at another problem, and it's going to be real similar to this. It says, this is actually from an Ames practice book. It says, how much greater is the volume of a cube when the length of each edge is multiplied by 3? And so again, you don't have to worry about drawing this cube out. You can, but the key word here is you want to look for, it says volume, so that's the key word. And then it says it got multiplied by 3. That's the same as each side getting tripled. Okay, and so it got 3 times as big. So volume, what you want to think about for volume is, what are the units for volume? So if it was like each side was, a centimeter, right? Your volume units would be centimeters cubed, because volume is 3-dimensional, so it's raised to the 3rd power. Okay, and so what we would do is we would cube these things. So this got 3 times as big, so we're going to take that 3 and we're going to square it. Sorry, not square it. It's volume, so we're going to cube it, right? And let's say this said, instead of volume, let's say this said area, right? Just like before, we would take the 3 and we would square it, right? Because area, the units are squared. Let's say this said surface area. Okay, this said surface area. Again, you think about what are the units for surface area. Well, the units for surface area are, if it was in centimeters, it'd be centimeters squared. So again, if it was surface area, you would say it got 3 times as big, and so you would square it, because surface area is squared. So the key to answering these questions is to look at what they're talking about. Are they talking about volume, surface area, or area? If it's volume, you cube the number of times it got bigger. If it's area or surface area, you square the number that it got multiplied by. So in this case, it got 3 times as bigger, and it was volume, so we cubed the 3. If it was surface area, that's squared, so we would take the 3 and we would square it. And those are kind of the 2 instances. So in this case, it was 3 cubed for volume, so our answer would be D. 3 times 3 times 3 is 27. All right, let's look at 2 more questions here, and then you can try some of these on your own. So it says the area of a larger square is 16 times the area of a smaller square. How many times as long is the base of the larger square than the base of the smaller square? And so here it's kind of, you have to work backwards. So before, they told us how many times bigger it got, and we had to see the effect on the area. And now they give us the effect on the area, and we have to figure out how many times bigger the sides get. So we got to work backward. So if you think about the inverse to work backwards, before, if it was area, we would square the units, correct? Okay. How do we go backwards? How do we figure out what's squared? So you kind of want to think about what number squared gets me 16. And so the only answer would be 4. So this is a case where you would have to work backwards. Okay. They give you the area, and they're asking you for the side length, or the base. Okay, and so you got to work backwards. And so if it was area, that means it's squared. And so we would think about what number squared gets me 16, and that would be 4. Okay, let's look at one more problem here. All right, and so this last problem here is a little bit different, and let's read it, and then I'll talk about why it's different. So it says the length of a right rectangular prism was multiplied by 4, the width by 3, and the height by 3. So what was the corresponding effect on the volume? Okay, and so the reason this is different, if you haven't figured it out already, is that each side is being multiplied by a different number, or I guess two of them are multiplied by the same number, but one is different. Okay, and so if we go back to 2 problems ago, we look at this one. It says, how much greater is the volume of a cube when the length of each edge is multiplied by 3? And so here, each side was multiplied by the same number, and it was 3. And so what we did was we took that 3 and we just cubed it. We times it by itself 3 times. Here, this is different because each side is different. So what you want to do when each side is being multiplied by a different amount is you want to take those numbers and you want to multiply them all together. So in this case, it says the length of a right rectangular prism was multiplied by 4, the width by 3, and the height by 3. So what I would do, because its volume, is I would take 4 times 3 and then times another 3. Oops, I don't need 2 3s. Let's redo that and just erase. Times another 3. You probably already got the answer, but so 4 times 3 times 3. So 4 times 3 is 12, times 3 is 36. Okay, and so that right there is going to give me the effect on the volume. So the volume would increase by a factor of 36. It would get 36 times bigger. Okay, so I guess what you have to memorize for this one is when you have when you're finding the volume and the effect on the volume, and each side is multiplied by a different amount, you need to take all those numbers and multiply them together. All right.